Hello, everyone. Let's start. So today, I would like to give an update on some of the stuff that we've been working on, and then we will open up to questions. So one of the items that we discussed last week was equivalence cache. Equivalence cache turned out to improve performance in certain situations, and later on, when we looked at it further, we realized that it may not actually improve performance of all the predicates. It turns out that it's useful for those predicates that are more computationally expensive. Some of the predicates that we have are pretty lightweight in a way. For example, we have pod fits host. Pod fits host only checks if the given node name is equal to the name of the node. So it's basically a simple string comparison. Moving some of the predicates like this to the equivalence cache causes multiple cache lookups that actually degrades performance instead of improving it. So we need to, we think that we need to change the equivalence cache to only cache some of the predicates, those predicates that are more computationally expensive. An example is interpod affinity and anti-affinity. When we tried equivalence cache for some of our benchmarks that are targeting only anti-affinity, we saw 16x performance improvement, of course, in our benchmarks where a cluster size is pretty large and we are scheduling a relatively large number of pods. But anyhow, this number is quite significant. So we believe that equivalence cache is important and is useful, but we need to change it to make it basically predicate-based. If the predicate is lightweight, we don't need to cache it. We just can run the predicate itself. If the predicate is more expensive, we can use the equivalence cache. One of the ideas that I had was to maybe make the predicates themselves aware instead of just equivalence cache being aware of the predicates and each predicate, whether it's worth caching or not. Instead of that, we can just change the predicates a little bit to become cache aware and let the predicate themselves choose whether they want to use the equivalence cache or run the predicates. The benefit of this approach is that every time that a new predicate is added, that predicate itself should be actually should get optimized for running with the equivalence cache or not using the equivalence cache. The alternative, which is like equivalence cache, knowing about each predicate, has the drawback that every time that a new predicate is added, we need to go and make changes to the equivalence cache as well. Since Harry has been working on this project, I let him add any more details since he's present here. Harry, do you have any further details or updates for us? Okay, he may not be hearing us. All right, so another item that we have is moving things node by condition to beta. I saw that the PR to actually promote the feature to beta is sent to me and I LGTM'd. Wei, you are here. Do you have any further updates for us? Everything looks to be on track, right?
Yeah, so the modification in QFeatures.go seems to have been merged today. So I think the last item is the website. So Klaus promised to review this week. So when that's done, we can kind of close this. And I will contact them to see them if them needs any release notes or not. Then we can close this.
Sounds great. I guess Klaus is not present today, or at least I don't see him. So with respect to gang scheduling, we have had some discussion with the community and the PR that Klaus has written for the proposal, and we think that we are almost there. We have a good idea of how we want to create the API for gang scheduling. And then the next phases will be starting to implement some of these. We think that we are going to build a separate scheduler called batch scheduler for just doing gang scheduling and batch scheduling. We also need a controller that takes care of lifecycle events of gangs, or pod groups as we call them now in the API. The controller is responsible for taking action when certain properties of a pod group is violated. For example, if a pod group requires a minimum number of pods, what should we do if the number drops below that? The number of pods drops below that number, the required number. So events like that, whether we should wait for those or whether we should kill all of the instances and all of these decisions or take action taking, is going to happen by that controller. Is there any particular question about gang scheduling? All right. So let me see. There has been a couple of other items that I have been working on. One is actually the scheduling framework. There is a proposal out for the scheduling framework. I already told you guys that we think that building a separate scheduler from scratch needs a lot of effort, and also rolling it out will be a little hard, given that there are so many users that are relying on the specific properties or behavior of their current scheduler. Replacing it with a completely different scheduler, although it's mostly backward compatible, may not be very easy. So as a result, we've decided to gradually bring the ideas of the scheduling framework to our current scheduler. And we think we are going to start with some of those that help move the dynamic resource binding that are currently partly in extenders, partly in the scheduler code, basically are moved to plugins for our current scheduler. And these could be like in-process plugins. That's the current direction that we want to follow. I have updated the proposal to reflect this new development plan. If you have any questions, you can ask now, or you can take another look at the proposal and leave your comments. Any question about scheduling framework? All right. Another item that I've been working on was scoring fewer nodes in a cluster. Basically, the idea here is that once the scheduler finds a certain number of feasible nodes for scheduling a pod, it stops the scanning and doesn't go on through all the nodes in the cluster. The reason that we decided that we are going to do this is to improve performance, basically. So especially in larger clusters, we probably don't need to go through all the nodes once we find a certain number of nodes that are enough for running a pod, and we can start scoring only the set of nodes that are found. We see some performance improvement from this. It has been in the ballpark of like 30% in larger clusters. In smaller clusters, actually this feature is not going to have any major impact, and it's not going to be actually be active in a way. So in a small, since we are expecting to score a certain number of pods at a minimum, a certain number of nodes minimum, in a small cluster, that minimum is oftentimes less than the size of the cluster. The minimum is larger than the size of the cluster, and as a result, we are going to end up scoring all the nodes. So this is a particular optimization that targets larger clusters and improves the scalability of our scheduler for going beyond the 5,000-ish node that we can support today. Any question about that feature?
Yeah, one question on this. Does that mean we don't iterate all the nodes? So does that also mean that we might not be able to find the most optimal node fit, right?
That's correct. Yes. So yes, that is very true. I actually there was some discussions about this on that PR. The gist of it is that the most optimal node for running a particular pod is not necessarily very stable choice anyway. So let's say that, for example, you're trying to spread pods among nodes, and you're trying to balance the amount of resource usage among nodes. You may go and find the perfect node in the cluster that gives you the best balance of resource utilization. 1 second after the node is scheduled, another pod on a different node terminates, and suddenly a lot of resources become available on that node. So very soon that node that you chose a second before no longer is the most optimal node or the optimal node for running the pod. So this is in practice not necessarily very useful. At least in larger clusters, this is where there is a lot of churn. Picking the most optimal or the optimal node is not necessarily worth a lot of extra activity and a lot of extra computation. Does it make sense?
Yeah, thank you.
Sure.
I'm just wondering if that's being thought of in a power optimization way as well. If you're, as you're scanning parts of the cluster, if that's being done with some larger goal in mind.
So in terms of power, are you referring to like failure domains and power sources in certain sites?
No, I'm thinking of it more like just power usage overall. If let's say you have a large cluster that's half in use, if you keep half of the nodes busy and half of them idle, you've got a better power situation. Now failure clicks with that, but what are the larger metrics that's going for other than being faster?
Yes, that is true. That's valid. Although we are intentionally actually, in order to provide a better spreading in clusters, we actually go through different failure domains instead of just, today our scheduler actually starts looking at all the nodes in a cluster in a sort of like a very linear manner. It just goes through the list of all the nodes and scores and checks the feasibility of all. When this new feature is merged, the way that we are looking at the nodes becomes slightly different, or maybe fundamentally different.
Yes.
So what we do is that we actually go through different zones and different regions. Basically, let's say different zones. That makes things easier because anyway, the different zones in different regions are still different zones. So basically, we go through different zones and we pick one node from, let's say, zone 1, we evaluate it, and then the next one is chosen from the next zone, and the third one is chosen from the third zone if there are multiple zones in a cluster. It's not just a linear scan anymore. And once
I'll take if you can link that proposal, I'll take a look and comment there.
Sure.
I think there's definitely some power concerns there.
I see. Yeah. For power optimization, we actually can have another priority function that.
Of course. I'm just saying.
Right. So I guess for that, for the purpose that you have in mind, our best priority function is most used. So we have this priority function that tries to actually maximize the usage of resources on a node before going to another node and so on. So basically, that's something that can be used to optimize power usage.
Okay. Thanks.
Sure. Okay, Klaus is here now. Hey, Klaus. Since you're here, I let you. Hey, no problem. So, since you're here, I let you give us an update about gang scheduling.
Oh, for the gang scheduling, I think I update the document according the meeting last week, and I think in the last week we put a lot of discussion about the kind of transaction of the whole pod group. And I checked the Slurm as I append in the issue. Slurm also did similar things to the admission controller, but the thing one difference is that Slurm based on the in job level. Yes, but in Kubernetes, it's do the admission pod by pod, almost in pod level.
Right.
I think this is the major difference. And I also check this with in our product. We all do the similar things. So we also do the kind of admission in job level. So for batch system, they don't have such kind of issue. But for Kubernetes, because we don't have a concept of job, right? So that's going.
Kind of. So a job can also be a collection of pods.
Yes.
So we have that kind of a concept in Kubernetes as well. A lot of our collections have the same.
Yeah. I mean, this concept is in Kubernetes, they do the most of things in pod, right? But in batch system, they almost do everything based on job. I think that this is a kind of major differentiation. But I think we need to have some proposal or some solution to for this kind of issue, how to resolve that.
Okay.
Yeah, I open some wishes here.
Yes.
Yeah.
Wish is here
I
too.
wish. Yeah.
Hello.
Yeah.
So we were just discussing the admission and for gang scheduling, and the fact that we don't have transactions, so we cannot basically admit all or none in Kubernetes. And Klaus was telling us that Slurm does it by job. Basically, the job is like a collection of tasks. Is that right?
Yeah.
In Slurm. So
So at the end of the day, like the thing that Slurm is looking at is the aggregate amount of resources, right?
Yes, I believe that's the case, right?
I'm
not
actually
familiar
part
with
of
all of these.
scheduling.
Right.
I want to understand if when Slurm admits a job, does it mean that it has scheduled the job, or has it just placed it in its scheduling queue, and it may eventually not schedule, like it may remain unscheduled, for example.
I don't know about that. Do you know, Klaus? Do you know whether if the admission in Slurm has the same meaning as Kubernetes? So in Kubernetes, we have an admission controller that is basically a very
I think they don't have they use a different term. They have a plugin named job submission plugin. So when job submit to the system, you can accept or reject or even modify the job when they submit or do the modify. So map to the Kubernetes, that's going to be when they create or when they update, when the object is updated. So they don't use different. Slurm use different term, but I think something is similar. Yes. Yeah. I append a document link, so they give a demo on how to have a plugin for this kind of, how to do the plugin for submission, for job submission.
The other thing we might want to look at is like Uber developed some sort of a Mesos framework for doing gang scheduling.
Yes, I also use talk to Uber.
Okay.
Yes, yes, they Uber build a batch system based on Mesos, and I think they also I use a talk with Uber how to build another batch system based on Kubernetes. Yes, I think I use a talk to them. I think their major concern is about the performance.
Performance of what?
Performance of throughput. Yes, for our products, there are going to be 1 million tasks per day. And I think when talk to Uber, I think their throughput or the scalability are almost similar.
Yeah. So they actually wanted to have like larger clusters as well, right?
Yeah.
They wanted to have like 10,000 to 20,000 node clusters.
Really?
Yeah.
Like, oh, you mean in Klaus's case, is it?
Or
Uber wanted to. So this is the
I
system
think
that I heard sort of like secondhand from Uber as well.
okay,
That they prefer to have larger clusters. I don't know, maybe they have larger jobs, or maybe they prefer to combine multiple jobs to improve resource utilization.
yeah, it's like this number, the 1 million sort of translates to about 12 pods per second, right? So if we did not have to, yeah, so if you don't like take into account storage provisioning latencies, and if you don't take into account say affinity and anti-affinity crap, like because of this crap, so then like that number isn't that big, except that the rest of the system should scale, which is much more of a problem.
That's exactly right. So the rest of the system is actually the problem.
I think the key relevant point here is they're making the decision at the gang level, or what's called a job, which is a series of tasks. They're making it at that gang level, not at the individual, what would be a pod level. So the lack of transaction is the problem.
Right. So the model might be different, and maybe they want to have like transactions, and we don't support transactions as of today.
So there's parallel from other systems.
So Bobby, I think someone from Alibaba, I don't remember his name, but he has mentioned that they are using a variant of gang scheduling, and default Kubernetes scheduler could not scale. I think it's Hong Chao Deng or someone from Alibaba who, and they told it's around like 10K plus nodes or 15K plus nodes scale that they are able to use. And they're using some variant of gang scheduling. I'm not sure, but he has posted a link on one of the GitHub issues that we have created for gang scheduling. I'll try to.
Interesting. Okay. That's good to know. If you know the link, please share it maybe on SIG Scheduling Slack channel. Or well,
I think it was in Chinese, or there was some problem related to that.
Okay.
But I'll post the link. I think I found it.
Like maybe scale is probably not the first thing you should target, right? Specifically for this feature.
Yeah.
If you don't have a parallel with other systems, then we're sort of like treading new territories here.
Right.
Which reinforces our original thinking that we should try it out of tree to begin with. And so that leaves us with the few options that we have now, which is like either have aggregate resource requests and do admissions based on aggregate resource requests.
Yeah, right. That's one of the options, right?
Or I forget what other option we have.
So the problem with that approach, the aggregate resources, that eventually we still do one pod at a time.
Yeah.
So we have to somehow tell the admission controller that, hey, you have already accounted for these, let them pass or something. So you have to make some logic changes anyways into our current
and it's just basically like creating another queue.
Yeah.
And that queue
ensures
that the other set of resources are not more committed.
Yeah. In case of Slur, I think there is a queue. There is a queue and
Yep. Yeah, I think a queue is I think there may be different from the concept of, because the queue is more about for the to share results. For example, high priority queue and how to share results between the different tenants, such kind of things. But for the gang scheduling, I think even we have queue in Slurm, such kind of concept, we also need to handle maybe transaction, or maybe we don't have transaction eventually, but we give some practice how, for example, for the controller, they try to create a job one by one instead of introduce any deadlock. So only one job will impact because of automation controller.
Yeah, so this is, I don't think this is something that we can really resolve and find perfect solution in this short meeting. This is something that we should actually follow up. This is one of the pieces that is left to be decided. I think the API part of the gang scheduling is kind of getting there. I think like creating pod groups.
Sorry, I think Legit gave comments about to use the label or annotation instead of a field of a pod. So I'm not sure.
Instead of failure, you said?
So for field.
Instead of field in a pod. I see.
Yeah.
Well, I think Baya and Grant will not like that idea at all, but
I think what he's saying makes sense, right? In the sense that if you're trying to develop this in a secondary scheduler,
right,
just to prove
of course.
Then for that phase, at least
as a proof of concept, definitely. Right.
The only thing to keep in mind is like if you want to eventually transition that annotation back into a field, then that is not possible today. And that gets pretty ugly. So we should be ready to tell our users that there will be a breaking change in the future,
right?
Or
make sure that everybody knows that this is an alpha feature and it's not going to be bad.
Yes. I think we can follow the alpha feature before. For example, we give a annotation key, right?
Yeah.
And so when we have some solution or some proposal about the transaction, we can introduce another field in the pod when we upgrade to the beta or GA.
Yeah. My gut feeling, boy, I want to actually hear your opinion, everyone else's opinion. It's just like it may take us quite a while to figure out the best possible design. The other approach we could take is can say this is the best option we could think of now, and then have a prototype for that, and then start solving the higher layer problem, which is defining a controller or extending the existing job controller to actually handle the lifecycle semantics that we need. And then seeing whether the whole system makes sense for a real application, right? So that way we can iterate our design through real world feedback.
Yeah, that makes sense. That's actually, I think, what we have been trying to do so far.
Okay.
Really. So we have been going through this, and we were thinking about bringing Kube Arbitrator as a batch scheduler, and moving forward with probably creating another controller, all as alpha features at this point. And then based on the feedback that we receive, we may, I don't know, in the future, we may decide to even merge the schedulers together or do something else. I don't know. So this is basically what exactly we said. So we're just testing some of the ideas here. So since we're running out of time, I would like to quickly follow up with Wei about daemon-sensitive scheduling by default to scheduler. So is there any further updates for us, Wei, on scheduling daemon sets?
That's one major issue, which is kind of respect the intent, right? Once we enable the feature. So that issue, I think it needs Mike, what? Let me check. Okay. Needs the daemon set approvals approved, but I pinged him a few times.
I think it's Mike Dennis.
Yes, correct. Yes, but he didn't respond. So
I can.
Thank you. So I can give you the issue number.
Yeah, sure. I know that issue. Okay. So there was also, we have been working on scheduling policies, pod scheduling policies as well. I had a very good meeting with Tim Alcala last week, and he has had some ideas. Yasin is going to update that proposal that is already out, and with this new changes to the design. The changes are not there yet, but we are hoping to see the proposal updated in the next couple of days. Is there anything else, since we're running out of time, is there anything else, questions, comments about any other features that you guys are working on? All right, Vish, do you have anything else that you want to talk about?
No, even though we run out of time, we should probably not be talking.
Yeah, all right. So thanks a lot, everyone, and see some of you folks next week.
Okay, see you. Bye.
Thank you. Bye.